This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. We're continuing to graph trig functions. We're still working on the sine, and we're going to do some problems where we need to determine the period for the sine function and choose the 5 key x coordinates, which will help us get the 5 key points, and then we'll graph. Alright, so it says find the period of y equals sine of 3x and state 5 key points and graph. Alright, now there are a couple ways of getting the period. You can use the formula, which is you take the coefficient of x, which is 3, and that's b. So we have b equals 3, and the period for sine will be 2 pi over b. So in this particular case, it would be 2 pi over 3. So that would be the period for this graph. The other way to do it is you know that you can just put 3x in between 0 and 2 pi because 2 pi is the usual period for y equals sine x. And then if you divide everything by 3, you've solved for x. And so that tells you that you have a period between 0 and 2 pi over 3. So again, you'll get a period of exactly 2 pi over 3. Now down here we have the sine function, y equals sine of x, and it goes from 0 to 2 pi. Now this is going to be much shorter. It's only going to go in between 0 and 2 pi over 3. So the trick is figuring out how you're going to mark your x-axis using that information. So here's the idea. I'm not going to draw the whole x and y axis, but let's just think about the x-axis. So you know the period starts at 0 and it ends over here. You know, one cycle ends at 2 pi over 3. You need to have 5 key points. That's the first key point and the last key point. So I need the one right in between here, right in between here. So there's a couple ways of doing this. This is the way I think is the easiest. If you get a fourth of the way there, and then another fourth of the way, and then another fourth of the way, and then to the end, you've got your key points. Since you're starting at 0, a fourth of the way to there is simply a fourth of 2 pi over 3. All right, so what is a fourth of 2 pi over 3? Well, let's see, you can cancel here. And that gives you pi over 6. All right, so this should be pi over 6. Now, so you've gone from 0 to pi over 6 for your first key x coordinate. So you have to go pi over 6 again. Well, just add that. That's going to be 2 pi over 6. The third one's going to be 3 pi over 6. And the fourth one is going to be, of course, 4 pi over 6, right? But that is the same thing as 2 pi over 3. Again, I'm just writing them all with a common denominator because it'll be easier to graph if we think of it that way. All right? So again, if you figure out what 1/4 of the way is, okay, that's just 1/4 times that period, 1/4 of 2 pi over 3, you're going to get the first mark. And then you just add that again to get the second mark, add that amount again to get the third mark, and add that again, and you should end up at that last spot at 2 pi over 3. All right, given that, now we're going to draw the x-axis and the y-axis, but we're going to use pi over 6, right, for each of our marks on the x-axis. All right, let's see, I forgot to write the original up here. It's the sine of 3x. That was our problem. Y equals sine of 3x. We found out that the period was 2 pi over 3. We came up with these key x coordinates. Now what are the y coordinates? If we're plugging in these x coordinates, we should get the normal y coordinates 0, 1, 0, -1, 0. And you could verify that. For instance, put in pi over 6 into this equation, the sine of 3 times pi over 6, you'll get the sine of pi over 2, which is 1, etc. So you could do that for all of those. But if we're changing these ordered pairs, we should be able to get those 5 key points that we normally get on the y-axis. So now we're ready to graph the function. Right? I've got it going from 0 to 4 pi over 6 or 2 pi over 3. It doesn't matter. So let's say I just kind of have the x-axis over here. And notice there's nothing in front of the sine, so we know the amplitude is still 1. So we know we're just going to go up one space and down one space. But here for our markings, we can do, well, we've got it in terms of sixths. 1, 2, 3, 4, 5, 6, 6. That's where pi goes. Okay? And you could fill in the rest of these if you want. You could say that's pi over 2, or you could say that this is pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. It does get a little bit crowded here when you start graphing. So let's do it. We've got 0, 0. Then we have pi over 6, 1. So we go 1 over, 1 up. Then 2 pi over 6, 0. Then 3 pi over 6, negative 1. And 4 pi over 6, 0, and there we have a complete cycle. If we kept going, we would now go over 1 and up 1 again, right? Go over another space, we'd be down at 0 again. Go over another space, you'd be down here. Whoops. Down here, etc. Same thing if I would have moved over to the left. So I know it's going to look something like this. Sketch it very carefully so it's nice and curvy. Whoops. And there we have the graph of y equals sine of 3x. And what's important is that your markings are carefully drawn on the x-axis. Okay? So if you want, you could say that this is pi over 6. There's room to put the pi over 6 there, right? So that might be helpful. This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.